Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn and today we're going to be learning about divisibility rules. So, what are divisibility rules, I hear you ask? Well, it's very simple. All it is a way to identify whether a number can be exactly divisible by another number or is a factor of another number, but we don't actually do the division. So we're not doing a bus-stop method or anything like that. We'll be doing other tricks. I'll start with something that a lot of you have already figured out or should already know, and that's to identify if a number is divisible by 2. So, if you want to know if a number is divisible by 2, well, let me give you an example and maybe some of you will already know it. I propose that the number 3,752 is exactly divisible by 2. How do I know this? Well, it's because the last digit is a 2. Let's do another example. The number 196. I know that that number is divisible by 2. How do I know that? It ends with a 6. We'll do one more example. I know that the number 49,738 is also divisible by 2. How do I know that? Because the last digit is an 8. So, by looking at the last digit of a number, think about the 2 times table. I'll write it out. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You can see that the last digit alternates between 2, 4, 6, 8 and 0, and so on. 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. So here's the rule. Let's write it down. The last digit is 0, 2, 4, 6, or 8. Now let me ask you a follow-up question for those of you who want to have a little bit of a think about it. Okay, so now that we've seen the digits that it can end with, let me ask a follow-up question for those of you who want to think about it a little bit more. Is the number 0 divisible by 2? Follow the logic. 0 divided by 2 is 0, and it does end in a 0. So the logic holds. 0 is in the 2 times table. Alright, next is dividing by 3. How can we tell if a number is divisible by 3 without doing the division? So, I will write 2 examples on the board. The first number, 171, and the second number, 40,962. I know that both of these numbers are exactly divisible by 3, but I haven't done the division. How do I know that? Well, the trick is easy. All you have to do is add the digits together. If you add 1, 7 and 1, you get the number 9. If you add 4, 0, 9, 6 and 2, you get 21. Both of those numbers, or both of those totals, I should say, are in the 3 times table. If the sum of the digits is in the 3 times table, or a multiple of 3, the number is exactly divisible by 3. So let's write that down. The sum of the digits is a multiple of 3. Very straightforward. Now we'll move on to the next number, dividing by 4. Alright, the next number is dividing by 4. Now, the trick with this number is that dividing by 4 is equivalent to dividing by 2 and then dividing by 2 again. So the rule is actually very similar to the rule for dividing by 2. Looking at the last digit. I'll give you 2 examples 732 and 11,948. Those two numbers I know can be exactly divided by the number 4 with no remainders, yet I haven't done the division. I don't even know the answer to them. But how do I know that they are exactly divisible by 4? The trick is, look at not the last digit, but the last 2 digits. 32, 48. All the other digits beyond those are irrelevant. They can be whatever. But 32 are the last 2 numbers here, and that's in the 4 times table. 48 is also in the 4 times table. So the rule is that if a number is divisible by 4, the last 2 digits are a multiple of 4. Easy enough. So because 4 is made of 2 times 2, and dividing by 4 is made of dividing by 2 and then dividing by 2 again, the rule is very similar. Let's move on to the next number, dividing by 5. I'm going to write down 2 examples of numbers that I know are divisible by 5. 435, 6,185. And maybe one more example. Let's have 4,370. I know all of those numbers are divisible by 5. How do I know that? I'm sure you know this one as well. It is that the last digit is either a 5 or a 0. Very easy. If you look at the 5 times table, 5, 10, 15, 20, 25, 30, you can see how the pattern keeps repeating itself. So let's write that down. The last digit is either 0 or 5. Very easy. Let's move on to the next number, dividing by 6. Okay, here's the next number, dividing by 6. The number 70,422 is divisible by 6 because it obeys both the rules of divisible by 2 and divisible by 3. 6 is made from 2 times 3, so all we do is check, does the number fit both the rule for dividing by 2, is it even, ending with 0, 2, 4, 6 or 8, and is the sum of the digits in the 3 times table. In this case, yes, if you add the digits, 7, 0, 4, 2 and 2 add up to 15, and it ends with a 2. Therefore, it is divisible by 6. Now, we would move on to dividing by 7, but 7 is a very awkward number. There isn't an easy rule for looking at a number or doing a trick. So we'll leave that. If you have to check, just do the division, divide by 7 in the bus stop method, or whichever method that you use. Next, we'll move on to the number 8. Okay, to divide by 8, here's an example. 13,976. I know that this number is divisible by 8 without doing the full division. All I'm going to check is the last 3 digits. 976 or 976. This comes from the fact that dividing by 8 is dividing by 2 and dividing by 2 and dividing by 2. So the rule should be very similar to dividing by 4 and dividing by 2. We're going to check the last 3 digits and check if it's a multiple of 8. So if you do the bus stop method for just the 9, 7 and the 6, you can ignore all the preceding numbers. Those are the only ones that matter. So let's write down that rule. There we go. The last 3 digits are a multiple of 8. Now let's move on to dividing by 9. Alright, so to divide by 9, here are 2 examples, 432 and 8,721. Both of those numbers are exactly divisible by 9. And the rule comes from the fact that 9 is made of 3 times 3. So dividing by 9 is just like dividing by 3 and dividing by 3 again. So what was the rule for dividing by 3? It was to sum the digits and check if the result is a multiple of 3. Well, the rule is very similar. If you add these digits together, 4, 3 and 2 give you 9, and 8, 7, 2 and 1 give 18. This total must be in the 9 times table, or a multiple of 9. So very similar. We sum the digits. The sum of the digits is a multiple of 9. And that's it. Very easy. Let's move on to dividing by 10. Okay, let's move on to dividing by 10. Here's an example, 8,730. All we have to do is check the last digit. Now, I'm sure many of you already know this. If you look at the 10 times table, 10, 20, 30, 40, and so on, the last digit is always a 0. And that's all we're going to write down. The last digit is 0. Now, that was really easy. Let's look at it a little bit more in depth. What is 10 made from? 10 is made of 2 times 5. So what's the rule for dividing by 2? And what's the rule for dividing by 5? Remember, dividing by 2, the last digit is 0, 2, 4, 6, and 8. And dividing by 5, the last digit is 0 or 5. So to divide by 10, we need to obey both rules at the same time. There's only one number in both lists, and that's the number 0. Hence, dividing by 10, check, does it end with a 0? Easy enough. Let's move on to dividing by 11. Okay, the final number in our list is to divide by 11. So I've got 2 examples on the board, the number 495 and 8,723. I know that both of those numbers are exactly divisible by 11 without having done the division. How do I know this? Well, the trick is to look at the sum of alternating digits. What do I mean by that? Well, let's look at the number 495. If you add the 4 and the 5 together, you get 9, which matches the digit in the middle. If you look at the number 8 and 2, the total is 10. Then look at the remaining digits, 7 and 3, and that total is 10. So the rule for dividing by 11 is to add the first, third, fifth, seventh, and so on digit, then add the second, fourth, sixth, and so on digits, and if those totals are the same, then the number can be divided by 11. That one is a little bit more involved, but it is actually quicker than doing the division itself. So, what did you think about all of the divisibility rules? Hopefully they help you out. They'll be useful for later on in mathematics. But until then, make sure you like, comment and subscribe if this video has helped you. Take care.